Next, I'm going to talk about vector 1. Now on my paper here, I do not have vector 1 drawn in. So what I'm going to do really quickly is I'm going to take and put in my vector 1 so you can see where it is briefly. I'm only going to put one of them in. The other one's going to look exactly the same. So here is my vector 1. And this time I'm operating in blue. Okay, so now I'm color coding and I'm looking in the blue. So my vector 1 happens to be the vector that's going up and to the right. So now for this particular set of math, here's what we've got. We've got vector 1 in blue, and it's going up and to the right. So it has an up part, or an Fy. It has a right part, or an Fx. Again, I'm doing the vector components. I labeled my side. This is the angle. Go through the center. The side across is the opposite. Here's my 90-degree angle. The side across from that is my hypotenuse. Obviously, then this is my adjacent. So I used my sine formula, my cosine formula. My x is my opposite, so fx is going to go with the sine. And again, I've done the math already for you. I changed this 30 degrees to 45 because that's what I used on my triangle. I have no idea what yours is. Again, it's the same math as I had in vector 3. So I got the same 565.685. The total number of x's from problem number 10 on the design worksheet is still 6. So I'm still going to multiply by 6. In English, if you look at my side view, I have one that's going up and to the right and a second one that's going up and to the right. And there's two of those per side, so 2, 4, 6, so that's why I'm multiplying by 6. You're probably going to multiply by some other number, which means that all of my math is identical to my red. Is that going to be the case for you? Well, your x's should both be identical. Your y's should both be identical, but they may not be equal to each other. I still only have one significant digit, so I'm still going to round my 3,394 off to 3,000. Notice that I put positives for both of my x and my y. I did that because my y is going up and my thing is going to the right. How did I know this was going up and to the right? Well, the tower has to support the weights. If the weights are pushing down, then obviously the tower is going the other way by pushing up to balance it out. So the last thing I need to do is to look at vector 2. Now, what in the heck is vector 2? Well, vector 2 happens to be my straight line that is going up. It's the pillar. Now, the pillar, even though it might be made of 2 straws, it is made of the exact same plastic. That plastic is going to buckle no matter how many straws you have at approximately 800 grams. So even though I have 2 straws, I only get 800 grams for that whole vector. So one vector 2 is worth 800 grams. So if you look at the math here, vector 2, it's a little different. Notice it doesn't have any sine or cosine or any angle. And the reason is because it is going straight up. You don't need an angle. All 800 grams, not just a portion of it, are actually going to help support the weight. So if you look back at number 4 from your design worksheet, number 4 will tell you how many total pillars you had. I had 3. Because I had 3 total pillars, I'm going to take 800 times 3. 8 times 3 is 24, so 2,400 is going to be my calculator answer. After my calculator answer, there's another blank there, and that blank is for the significant digit answer. Again, I just have 800, so my significant digit answer is going to be 1 significant digit, or 2,000 grams. Now, a couple of things to note that I did on this particular paper, and that is that I have grams and grams and grams and grams and grams the whole way down. I made sure to include my signs. This is a positive, this is a positive. Vector 3, the x was a negative because it was going to the left. Y was a positive. And this one is pointing straight up, again, because it's supporting the weights that are pushing down. It's opposing them. So it's going to be a positive 2,000 grams as well. Please make sure you have significant digits. You have the pluses or the minuses, depending on which one it is, and you have G for grams at the end.